Hi everyone. Now in this class I am going to discuss about Unit 6 Gravitation. So gravitation means the force of attraction between any two bodies in the universe is called gravitation. For example, between the sun and earth there is a gravitational force. Okay, so the gravitational force means the force of attraction between any two bodies in the universe is called gravitation. So next, the state Newton's universal law of gravitation. So statement: every body in the universe attract every another body which a force is directly proportional to the product of their masses and inversely proportional to square of distance between them. So this tells that if you consider two bodies or object which having masses m1, m2. Between two bodies there is a force, gravitational force. So the distance between m1 and m2 is r. So consider any two bodies or object which having mass m1, m2. Between two bodies there is a force and the distance between two bodies r. Okay, next. So F force is directly proportional to product of their masses m1, m2 and inversely proportional to square of distance between them r square. So this tells that force is directly proportional to product of their masses m1, m2 and inversely proportional to square of distance between them r square. So next, F equals there is a constant proportionality symbol. So gravitational constant G, mass m1, m2 by r square. So this equation, force equals G m1, m2 by r square. G is a gravitational constant, universal gravitational constant. m1, m2 are masses and r is a distance. So G value constant, so universal gravitational constant G value 6.67 into 10 power minus 11 and force is measured in SI system Newton and masses and radius or distance is measured in SI system is meter. So meter square. Masses are measured in SI system is kg per minus kg minus 2 power minus 2. So G equals 6.67 into 10 power minus 11 Newton meter kilogram per second. So n m square kg minus 2. So this tells that the Newton's universal law of gravitation is every body in universe attract another body which force is directly proportional to product of their masses m1 m2 by inversely proportional to square of distance between them r square. Now I am going to discuss about arrive the relation between acceleration due to gravity small g and gravitational constant capital G. Okay. So now consider body of mass m small m. Consider a body of mass small m to be placed on the surface of the earth. To be placed on the surface of the earth, where capital M is a mass of the earth, r is a radius of the earth. So you know that according to the gravitational law, F equals G, capital G, m e small m by r e square. According to the gravitational law, F equals G m e m by r e square, where F is a force, G is a universal gravitational constant, m e is a mass of the earth, where small m is a mass of the body, re is the radius of the earth, re square. So re square. So the force produced to acceleration G, of the body of mass m. So according to the Newton's second law, Newton's second law of motion, according to the second law of motion, F equals mg, where force produced to acceleration G for the body of mass m. So considering it is a equation 2 and it is equation 1. So equation 2 and 1 will be F equation 2 force mg equals G equation 1 G m e small m by r e square. So mg equals capital G m e small m by r e square, where m and m get cancels. So remaining G equals small g equals capital G m e by r e square. g equals capital G into m by r square. So by r square. So when small g is a acceleration due to gravity, and capital G is a gravitational constant, me is a mass of the earth, re is a radius of the earth. So this equation shows that relation between acceleration due to gravity and gravitational constant G. Now another 5 marks question. Derive the acceleration due to gravity at a point above the earth surface. So let G is an acceleration due to gravity at point A on the earth surface. So let G is an acceleration due to gravity at point A at a point A on the earth surface. So G equals capital G m by r square, where small g is a acceleration due to gravity, capital G is a gravitational constant, m is a mass of the earth, r is a radius of the earth. So G equals gm by r square. Consider it is a equation 1. Let G dash is a acceleration due to gravity at point B above the earth surface. H is a height from the earth surface. So G dash equals Gm by r plus h whole square. So the total distance from O to B, r plus h. So r plus h. So consider it is equation 2. So divide equation 2 in equation 1. So equation 2, G dash by G equals Gm by r plus h whole square into equation 1, r square plus r square by gm, r square by gm. So in this equation, similar terms gm get cancelled. So remaining r square by r plus h whole square. So G dash by G equals r square by r plus h whole square. This can written as G dash by G equals r by r plus h whole square. R by r plus by taking r common in denominator. So r here 1 plus h by r whole square. Here r by taking r common in denominator, so r by r becomes 1, so plus h by r, so r by r 1 plus h by r whole square, so r get cancelled, so remaining g dash equals g dash by g equals 1 plus h by r square whole square. So this can written as another form, 1 by x square can written as x power minus 2, like that 1 by 1 plus h by r whole square can written as 1 plus h by r power minus 2. So here we can written as 1 plus h by r minus power minus 2. So using binomial theorem, for this expression, we can written as g dash by g equals 1 minus 2h by r. By using binomial theorem, this can written as 1 minus 2h by r. So g dash equals g 1 minus 2h by r. So this equation shows the acceleration due to gravity at point above the earth surface.